Okay, hi everyone. So in this video, I will cover some basics and the application of the single sample mean I covered today. So this is a first part of the statistical test I will cover in this semester. So it might be a little bit challenging compared with the other topics I covered so far. So please focus on the video, or before watching the video, it's rather better to read over the lecture slide before. But anyway, it's totally up to you. So which works for you, yeah, please work on that way. All right. Okay. So I covered the single sample mean, saying that, so let me go. So there are steps number 1, 2, 3, 4, 5. And step number 4 is calculating the effect of the D or effect size of the D. But I would not ask for you to do it in the exam, so you may disregard this part in this time. But anyway, so the basic concept is comparing the sample mean and the population mean. And usually we don't know about the population mean, such as the average weight of all the people in the United States, or the average consumption to the McDonald's in the United States or something. So we may have the data, but it's almost impossible to have the whole data in the United States. So the mu, so in this example, so number of the confirmed cases averagely in the cities, the state A. So state A is a very small subgroup of the United States. So which means that is a sample, which is subgroup. But we know, so maybe the mu, the Greek letter, the mu means the population mean. And averagely, in the older cities of the United States, there was 80 cases. There were 80 cases as the population mean. All the cities in the United States, population mean were averagely 80 cases in the cities. But in state A, possibly, so I'm randomly selected in the state, there were 85 cases in the cities of the state A. So the issue is, anyway, we are not using the manual calculation. So now we are just comparing the mean, population mean, and the sample mean, whether there was statistically significant difference between the population mean and the sample mean, or there was not a difference. There was not a statistically significant difference between the population mean and the sample mean. That was the basic background of the conceptualization. So I would allow you to read over those parts, but on this theory, if you do not full understand, so you can just keep over, but you do need to focus on what I covered in this part. So example 1 is based on the education level, which means the EDUC variable in the SPSS data. So in SPSS data, this is the Mac version, but anyway, you can go to the analyze the descriptive statistics and the frequency, and you can check EDUC, which is the highest year of education they had. So you may remember that 0 means the 0 year of education, 20 means 20 years of education. So you learned how to use it as the mean, median, mode, and maybe standard deviation or range, but we'll keep that way. Continue and OK. Alright, so this is a result showing that there are 2,345 cases. For some reason, there are 3 missing cases. The mean is 13.73. So averagely, in the data set, out of 2,345 cases, 13.73 years. 13.73 years of education was average year of education in the data. The median and mode, maybe you don't need to consider this time anyway. But anyway, so in the sample data, 13.73 years. 13.73 years of education. There was the average year of education. And the null hypothesis is, that's very cynical. There is no difference in mean years of education between the population mean and the sample mean. Population mean is mean years of education in the United States. Sample mean is their sample. So sample is, now we have the GSS 2018 data. So 13.3 years of the 73 years of education. There was no statistically significant difference between those means. Alternative hypothesis or research hypothesis is there is difference in mean years of education between population mean and the sample mean, and we will check it over. So as we showed you, so this is the Windows version. So this is a little bit different from the Mac version. But you'd go to the okay, click this one. You don't need to analyze. Go to the compare mean and proportion. Not this one, but we are going to the single sample mean, one sample t-test. Right? There is no corresponding menu, the sample match the one, but one sample. The one sample means single sample mean t-test. Alright. So now we have the education variable here. Right. I'm showing that. This is the Mac version and the Windows version. So here, same, right? We are choosing EDUC variable, which is the continuous variable or a metric variable. Because to calculate the mean, nominal variable is not available. Ordinal variable is not available. So metric variable, continuous variable is only available to use this test. So you can go to the EDUC variable and click here. And then you don't need to check any of the options. But the test value means the population mean. Saying that enter the possible population mean here because we don't know. We don't have any idea that what will be the education level of mean years of education in the population. We may search through based on the census data, but let's assume that we don't know exact number of the years of education, but let's suppose that we think the population mean of years of education is 12 years. So instead of 0, because 0, if we put 0, it means that you are thinking that the 0 year of education is average level of education over the United States. So put 12 here and OK. So before hitting that, let me explain that over. So after that, after clicking OK, you will see these two types of the tables. High year of education. The sample statistics means the descriptive statistics you could find in the frequency table or the descriptive statistic table. There are 2,345 cases, and the mean here, one sample statistic means the average of the sample data. So as you could see in the frequency table, in the previous one, so maybe here, 13.73, right, is totally same, right? So it's about that. And the test value was here, what you are assuming. The years of education, the population years of education is the mean of the population. And I mentioned that if the p-value, so here, you can check it over. If the p-value significance is bigger than 0.05, fail to reject the null. If the p-value is smaller than 0.05, reject the null. In here, null hypothesis was there was no difference. Alternative or research hypothesis was there is difference. Alright, so based on the outcome, it says that is smaller than 0.05, which means we reject the null. The reject the null, and the null was there was no difference. So as we reject the no difference statement, we say there is statistically significant difference between sample mean and the population mean years of education. Population mean was you put here, and the sample mean you could find here in the sample statistics. So you can argue that, and you can say that there was a statistical significant difference in that one. The p-value, what we say the p-value is what we say the significance value. We will keep that norm throughout this semester later on. The probability to have the true null hypothesis. Therefore, if it is smaller than 0.05, outside of 0.5, we can reject the null. It also means the possibility to have the true null is small enough below 0.5%. So very strict statistical theory, these are not 100% good, true, but for easier understanding in the undergraduate level of the statistics class or the research method, we will follow this rule. Okay? So we are not covering this in this time, but you can, I hope you can have some time, have some review on this lecture slide to see that. All right, so let's see. So 12, you can click OK, and then you could find that one, right? So this is the Mac version 13.73. This is sample mean years of education. 12, you put 12 as the assumed, and you're supposed to have the mean of the population years of education is 12. And we can see that, so we are using the two-sided here. The Mac version is a little bit complex, but we are always using the two-sided implication. So one-sided is we are not using on this semester because that's we are assuming that there is specific direction. You are using the two-sided, the two-tail outcome or two-tail statistical test. So as it is below 0.05, because it says the p-value significance value is below 0.001, which means that is smaller than 0.05. So we reject the null and saying that there is statistically significant difference between population mean 12 and the sample mean. All right, so that's very important part. All right, so single sample mean. So in case you assume that 14 years of education is the population mean years of education, then going to the compare means and the population single sample mean, everything same because we are using the same variable, but we are changing the 14 as the population mean and testing whether there is a statistically significant difference between population mean and the here 13.73, which is sample mean. Let's click OK. All right. So sample mean is the same because we didn't change the variable or the data, and we put 14 as the population mean. So whether there is statistically significant difference between 14 population mean and the sample mean. All right, still the two-sided p-value or two-tail test is below because it is smaller than 0.001, it's below 0.05. So we would say we reject the null and there is statistically significant difference between the population mean here and the sample mean. All right, no, not this one. Okay. All right, so let's try to find some very different outcome. So 13.7 is, in your guess, the population mean years of education, and then here 13.73. All right, so let's change the number. Compare mean. Alrighty, 13.7. Okay, and finally, the p-value. The sample mean is the same. The p-value is 0.605, which means it's bigger than 0.05, right? So we fail to reject the null. We failed to reject the null here, and the null hypothesis was there is no difference between the population mean, hypothetical population mean, and the sample mean. So we would say there is no statistically significant difference between population mean and the sample mean, right? So this is why there is no statistically significant difference between sample mean here and the population mean, or vice versa. All right, this is the first example. So example 2, days of the poor mental health condition, and so the variable is MNTHH something. So let me show you the frequency table. Alrighty. So quickly, MNTHL TH. Alright. So variable information saying that days of the poor mental health past 30 days. And then let's see. Alright. So 1408 cases. There are many of the missing values. I don't know why. The mean is 3.56. So indicates that in our sample data, General Social Survey 2018 data, averagely, the people had 3.56 days of the poor mental health days in the past 30 days. So this is a distribution. The median is 0. The mode is 0. So mostly they didn't have any of the days of the poor mental health, but we can find that. Sample mean is here. Alright, so using the sample, same one, the null hypothesis is saying that there is no difference. There is no difference between the population mean days of the poor mental health days and sample mean days of the poor mental health days. So it's very tricky to say that, but anyway, in the null hypothesis, they are denying, very cynical in denying that there is a difference in the mean days of the bad mental health. And the alternative hypothesis is saying that there is difference between the mean days of the poor mental health in the population mean and the sample mean. Alright, the menu is the same. Going to the analyze, compare means and the proportions, and the one sample mean, single sample mean t-test. So mn, so this variable. Okay, so how about the mean? So in your assumption or in your guess, so the first example we are using that, let's suppose that we think the population mean days of the poor mental health. We don't know about that because we don't have the data, and we need to collect the data from the 336 million people in the United States, which is not available mostly. So let's assume that, so averagely in the population, 5 days of the poor mental health, and click OK. So before clicking, let me explain. So in the sample statistics, 3.56, what you found in the previous table, the same. And the test value is our assumption. Based on our assumption, we assume that population mean days of the poor mental health is 5 days, right? And the result, the p-value, the statistical significant value, is below 0.000. This is a Windows version. So as it is below 0.05, we reject the null. We reject the null, which means we say there is statistically significant difference between the population mean and the sample mean in terms of the days of the poor mental health. Okay, let's compare that. 5 here. All right. 3.56 and two-tailed test below 0.05. Okay, it's consistent and you can follow the interpretation before. All right. If you put a different number, maybe you'll find a different answer. For example, analyze. All right. So let's put 3.5 as the mean was 3.56. Let's compare that. All right, so 3.56 as a sample mean days of the poor mental health, and assuming that 3.5 days of the average days of the poor mental health, and the two-sided p-tail test, two-tail test that is over 0.05. Okay. So comparing 3.5 and 3.56, there is no, because null hypothesis was saying that there was no difference. There is no statistically significant difference between the population mean and the sample mean in terms of the poor mental health days. Okay? So the terminology and the creating the arguments in the statement in the language is a little bit tricky, but it will help you to work on your lab assignment and the incoming exam. All right, thank you very much, and I'll see you in the next video. I mean the preview of the midterm exam. Thank you.